Given the graph of f of x equals the absolute value of x, shown here on the left, find the function rule based upon the graph of g of x, shown on the right, in the form of g of x equals a times f of the quantity x minus c plus d. If g of x is a transformation of f of x, we can always write g of x in the form of g of x equals a times f of the product of b and the quantity x minus c plus d. But because of the form they're giving us, we know b equals 1, which indicates we don't have a horizontal stretch or compression, but based upon the value of a, we may have a vertical stretch or compression. And because f of the quantity x minus c is equal to the absolute value of the quantity x minus c, we know g of x is in the form of g of x equals a times the absolute value of the quantity x minus c plus d. Sometimes you may also see the form shown here below, where c is replaced with h and d is replaced with k, where h comma k is the vertex. To begin to determine the function rule for g of x, let's track the vertex. Notice the vertex on f of x is 0, 0, and the vertex on the graph of g of x is -3, -2. This indicates the graph has been shifted left 3 units and down 2 units. The shift left 3 units indicates c is equal to -3, and the shift down 2 units indicates d equals -2. We now know g of x must equal a times the absolute value of the quantity x minus -3, which simplifies to the quantity x plus 3, and then because d is -2, we have -2. Now there's a couple of ways we can determine the value of a. Recall the value of a indicates a vertical stretch or compression, and if a is negative, we have a vertical reflection. We can see we don't have a vertical reflection, and it also appears we don't have a vertical stretch or compression. But one way to verify this would be to select any point on g of x except the vertex, perform substitution, and solve for a. Let's do this, and then we'll also analyze the graph to verify the result. Let's go ahead and select the point -4, -1, this point here on g of x. So if we select the point -4, -1, we would substitute -1 for g of x and -4 for x. This gives us -1 equals a times the absolute value of the sum of -4 and 3 minus 2. Inside the absolute value we have -4 plus 3, which is -1. The absolute value of -1 is 1. A times 1 is a. We have -1 equals a minus 2. Adding 2 to both sides, we have a equals +1. Because a equals +1, we don't have a vertical stretch or compression. And just to verify this, if we look at the graph of f of x, notice if we start at the vertex and move right, or x increases by 1, notice the function value or y value increases by 1. And if we try the same movement on g of x, starting at the vertex, if we move right 1 or x increases by 1, once again, the function value or y value also increases by 1. This indicates we don't have a vertical stretch or compression, verifying a equals 1. The function rule for g of x is g of x equals 1 times the absolute value of the quantity x plus 3. We can leave off the 1, and we have the absolute value of the quantity x plus 3, and then -2. I hope you found this helpful.